Good morning, third period. It's Mrs. Brooks here. So today I have a meeting and I will not be present for class. So I really am just posting today's Jamboard. I'm going to go through it, try to explain things to you guys. So your job today is going to be to watch this video and to follow along in your textbooks or your workbooks, volume 1, and make sure you have everything written in your notes, okay? So today we're going to talk about comparing relationships with equations. So we're going to develop methods for deciding if a relationship is proportional. So we're just building on from last week. Okay, so I'm not going to spend time on this right this minute because I don't have the ability to stop and pause and stuff like that. So we'll save the warm-up for a different day. All right, so we're on this idea of more conversions. All right, so the other day we talked about converting meters and centimeters, right? It's this thing when, remember, we had the X column and the Y column, and then we flipped it, right? And it was centimeters to meters, and we saw the relationship backwards and forwards. So today we're going to talk about some more units, okay? We're going to talk about the equation F is equal to 9/5 C, so let me go to that slide, sorry about that, 9/5 C plus 32, where F represents degrees Fahrenheit and C represents degrees Celsius to complete the table. All right, so I can already tell you that this relationship is not proportional just by looking at it, right? And that's kind of what it wants us to figure out. But I know it's not proportional because of that number, okay? So that number makes it non-proportional. But let's just go with it because it wants us to fill in this table. So I'm going to take my equation and I'm going to substitute. So I'm going to substitute 20 in for C. Okay, like that. And so now I can multiply, I can cross cancel. Some of you guys may be familiar with that. Some of you guys may be like, oh, Miss Brooks, I need a calculator. Okie dokie. So let me do that. All right, so if we have our cool calculator here, let me make it smaller. 9 divided by 5 times 20, bam, 36. So what that means is this amount is equal to 36. And then we add the 32. Okay, so plus 32. And that means our temperature in the F is 68 degrees when it's 30 or 20 degrees Celsius. Okay, and I'm going to do this process again, right? So I'm going to use the equation F is equal to 9/5. This time I'm not going to write 20. I'm going to write 4. Okay, and again, I'm going to use my calculator. 9 divided by 5 is 1.8 times 4 is 7.2. So that means this amount right here is 7.2, and we add it to 32. And we get 39.2 degrees Fahrenheit. Okay. And now we're going to do the last one. F Fahrenheit is equal to 9/5 times the Celsius, and the Celsius is 175 plus the constant of 32. And so we're going to divide it out. 9 divided by 5 equals 1.8 times 175 plus, so this value right here is equal to 312 plus 32. This is some really hot heat. Is 347 degrees. So when it's 175 degrees Celsius, it is 347 degrees Fahrenheit. That's what that means. Okay, so that's what we just did. We used the equation to to complete the table. Okay. All right. Now it says use the equation C is equal to 2.54 n, where C represents the length in centimeters and n in inches. All right, so now we're going to use the next one. So C is equal to 2.54 n, right? Where we're going to substitute n right here. So that means when it's 10 inches, we use our cool calculator, 2.54 times 10, and we get 25.4 centimeters in 10 inches. And then we're going to repeat. This time, instead of 10, we're going to type in or write 8 because that's the next number. Okay, and we get 20.32. And the last one, C is equal to 2.54 times 3.5. And I'm just going to put that in a decimal. All right, so 3.5 times 3.5 times 2.54. And we get 8.89. Okay? So again, it's just substitution into the equation. And it says, are these proportional relationships? Why or why not? So number 1 is not, because we have to add 32 degrees. Oh my gosh, it doesn't. Every time after we multiply. Okay. Also, if we divide y by, oops, that's not a y, sorry. Y by x, number 1 will be different. Every time. And number 2 will be the same. Okay. Let's prove that. Okay, so I'm going to take my calculator and I'm going to find the constant of proportionality by dividing the y value by the x value. So 68 divided by 20. Come on, dude. I'm going to write a little bit in the other. 68 divided by 20. Gives us 3.4. Bless you. Okay, the next one is, bless you, baby girl, 39.2 divided by 4 equals 9.8. And lastly, 347 divided by 175 is a repeating decimal. And if you notice here, all of the values in this column are different. 3.4, 9.8, 1.9. Okay, if we go to the other column down below and we take our y and we divide it by our x, oh my gosh, come on, dude. 5.4 divided by 10. And 0.32 divided by 8. Okay, I did something wrong. Let me try that one again. 25.4 divided by 10. Sorry about that. 2.54. And then the next one is 20.32 divided by 8, which is also 2.54. And 8.89 divided by 3.5 is 2.54, right? So just like what we saw last week, right? These are the same ideas when the column that you create by dividing the y value by the x, when it's always the same value, that's when it's proportional. So that's why 2 is proportional. Okay, 2 is proportional. You might have to pause here to make sure you have it all in your notes on in your workbook. Let me see what page real quick. We are in lesson 8, 2.8, which this is on page 128. Page 128. Okay. All right. So I'm going to go to the next slide. It says the total edge length, surface area, and volume. So how many edges are there? Okay. I'm thinking I might skip this. Okay, so let's go to slide 5. Slide 5 is on page 129. Okay, and it has some cubes with different side lengths. Remember, in a cube, all side lengths are the same. They're all the same measure. That's what makes it a cube, right? And a cube is made of a bunch of squares, and squares have the same measure on all sides, okay? So, here we go. This one is 3. That means all the way around, all those sides are going to be 3. This one is 5, which means length times width times height. They're all going to be 5. And this one's 9.5, which means length, width, and height are all going to be 9.5. So the next slide is the questions here on page 129 that have tables. So it's asking you, how long is the total edge length of each cube? Okay, so we're comparing all of them in one spot. Okay, all of them in one spot. All right, so each table is going to have all the different versions. Okay, so how long is the total edge length of each cube? All right, so that's why they wanted us to look at this. Okay, so in this slide right here, it says how many edges are there? So if we think about it, there's 1, 2, 3, 4, 5, 6, 7. Okay, let's talk back one. 8, 9, 10. The top 11 and the bottom is 12. Okay, so I'm going to go back there, and I just want you to note that there are 12. Oops, wrong. Okay, there are 12. And how long is one edge? Well, it depends on what the measurements are given. So again, in the one that we're going to talk about, it's 3, it's 5, etc. Right? It's 9.5. So how many faces are there on a cube? Okay, well, there's a front and there's a back. That's 2. There's a top and a bottom. That's 4. And there's a side and an other side. So that's 6. And how large is one face? It's going to be a base times height, right? If I wanted to know how big this base is, or face, is, then I have to multiply, right? And how long is one edge? That's going to be the length. All right, so now let's go back here. So we know that there are 12 edges because that's what I just went through. Okay, so how long is the total edge length of each cube? Well, if there's 12 edges, we say 3 times 12 is 36 because there's 12 edges. Okay, and then 5 times 12 because there's 12 edges again. This time each one's a little bit bigger, so that's 60. And now 9.5, maybe we need our cool calculator. 9.5 times 12 is 114. Let me write that, right? 9.5 times 12 is 114. And so what you'll notice here is that how we find that total length is by multiplying, right? We're constantly using the 12. So we put each side is equal to 12s, right? 12 times the side length, right? Isn't that what we did here? 12 times the side length, 12 times the side length. So we can even write it, the edge is equal to 12 times the side length. Okay, so now let's talk about the surface area, right? So the surface area, this is going back to, I think, last year, right? So the surface area of 3, think about it like this, okay? Surface area means 3 times 3, which means there's an area of 9 per surface. And as we said over here on this one, how many surfaces or faces are there? There are 6. So after we find the area of one side, we multiply it by how many faces there are. Okay, so we're going to take 9 and we're going to multiply it by 6. And we get 54. And then the next one is going to be a little bit bigger. It's going to be a 5 by 5, which is going to be a 25. Right? So now we're going to take the area of 25 and multiply it by 6. Okay, so 25, maybe some of you guys know this in your head, is 150. Okay, and then the next one is a little bit bigger, right? And it's going to be a 9.5 times 9.5. Oops, that doesn't look like a 9.5, sorry. And I need this guy, 9.5 times 9.5. Oops, that's not 9.5. 9.5 times 9.5 is 90.25. Okay, and now we're going to take that amount, 90.25, and we're going to multiply it by 6. All right. All right, so now what have we been doing, right? We've been squaring our side, right? Times itself, that's what that means, right? The side times itself, and then multiplying it by 6, right? So that's how we would say that one. The side squared times 6, okay? Now volume is where we find length times width times height, right? And let's go back up here. Area is length times width. So length times width times height, they're all going to be the same number, okay? They're all going to be the same number. So it's 3 times 3 times 3, right? 3 times 3 times 3. And we get 9. Okay, so the volume is going to be 9. The next one, 5 times 5 times 5. It's going to be 125, right? 1, 2, 3. There you go. Okay, and the last one, 9.5 times 9.5 times 9.5. And we get, ooh, that's a big one, 857.375, because that is 9.5 times 9.5 times 9.5. So really what we're doing is we're taking our side and we're cubing it, right? That little 3 means one measurement times itself again, okay? So which of these relationships is proportional? That's on the, probably on the next page. Yeah, it is on the next page. And so what we do here is, remember, we divide, right? The x and the y. So y divided by x. 36 divided by 3 is 12. 60 divided by 5 is 12. 114 divided by 9.5 is 12. So number 1 is proportional because these all equal the same amount. Okay? And so now we have to prove the next one, right? So here's x, here's y, and I'm just going to write it out here a little bit. Y divided by x. Okay, so we have 54 divided by 3 is 18. Okay, so that's this one right there. Now I'm going to take 150 divided by 5, and we're going to get 30. Okay, well, I notice right now that those two numbers are not the same. So I'm going to make sure by going to the last one, and we get another number, right? 541.5 divided by 9.5, and we get 57. So these do not divide to the same amount. Okay, they do not divide to the same amount. Okay, and so lastly, we're going to do, we're going to do the last column, x, y. I'm going to do that here, y divided by x. So we have 9 divided by 3 is 3. 125 divided by 5. Right, 125 divided by 5 is 25. Oh yeah, right. And the last one is 857.375 divided by 9.5. 857.375 divided by 9.5. And we get 90.25. Notice this column, they do not divide to the same number. Therefore, they are not proportional. So on the next slide, which is on page 130, it says, which of these relationships is proportional? So, oh shoot, I did it again. The first one is proportional because when we divide y by x, we get the same value. You have 5 minutes, baby, in every row. All right, so now it's asking for us to write the equations. Okay, so we're going to write the equations. And so the first one we already did is E is equal to, let me just go back again to let me verify. Oh yes, 12s. That's for number 1. Right, number 2, remember it has to do with a squared. So the area is equal to 6 times the side squared. And the third one is the volume is equal to the side cubed. and you didn't see what I was writing because I was on the wrong slide. Again, if you need to pause and write, please do so. Okay. Right. If you need to pause and write, that's fine. Give me 1 second here. Sorry about that. Give me 1 more second. Oh, shoot. I know. Thank you for your patience, everybody. All right, so I was supposed to start. No, you have 2 minutes and class starts. All right, so here we go. The next one says, what do you notice about the equation for each relationship? I don't know. So I don't think that question is in your book. Okay, it's not. All right, so the next thing I want you to do is in your books, we're going to talk about all kinds of equations on page 131. And so what this is this is a time to decide which ones of these are proportional. So how that's going to work is we're going to use substitution every single time. So I'm going to number them just so you can follow along. That's a horrible one. So this is 1, 2, 3, 4, 5, and 6. So number 1, I'm just going to do it up here. Number 1 says y is equal to 4 plus x. Now, before we get started, the idea here is number 1, to predict which of these equations represents a proportional relationship. So if we were in class, I would give you guys the time to put in your guesses, etc. And hopefully what you would notice is that anytime you have your equation y equals, and then you have kx, where k has a number and then x, that's your proportional relationship. Anytime that you have plus or minus something in your equation, that is no longer a proportional relationship. Okay? So we have to keep that in mind here. Baby girl, are you getting on your meeting?
I'm playing a game.
No, it's time. Sorry, guys. All right, so now the prediction would be that number 1 is not y because it has plus x. Number 2 is y because it doesn't have plus or minus anything else. Number 3, we'll come back to that. Number 4, we'll come back to that. Number 5, no, because it's got 4 to a indice, to a power. So this one it can't be. And 6, again, it has another power right here, raised to a power, so it can't be. All right, so now where we're at is we need to figure out, okay, well, 3 and 4 could be, right? It could be. So let's think about what it really means, right? Remember that when we multiply by a fraction, it's the same as dividing by that number. So what I'm saying here is number 3 is dividing it by x is the same as multiplying it by 1 over x. So this is the same.
Mama, why can't I move it over here?
Because it won't stay plugged in and your battery's dead. So nowhere did we learn, right, that x is a fraction, right? That's not 1 over x. So number 3 is not the case. So let's go to 4. So y is equal to x times 1/4. if we put this in the front, we have the formation of y equals kx. Okay. All right. So I am going to let you spend some time doing this. Okay. So I want you to pause the video after you see me do one example, and then I want you to come back. So how would we do number 1? Okay. How would we do number 1? So we would substitute the values in for x. So really it's y is equal to 4 plus 2, which is 6. Right? So then when we go to the next column, we say 6 divided by 2 is 3. And then we go to the next one. We use the same. Okay, we're going to use the same system here. Y is equal to 4 plus x. We're going to substitute the 3 in for the x. So we get y is equal to 4 plus 3, which is 7. So I'm going to go back over here. Hold on, please. It's the 2nd of November. So 7 divided by 3. And we get a repeating number. It's the 2nd of November 2, baby.
Oh, 2nd of November.
Okay. So because those two numbers are different, we can verify that they're not proportional. So I want you to finish number 1. And then I believe you all can do number 2 and 3. And let's go for 4. So I want you to do 1 through 4 on your own.
There's 70, 81. And 108.
Do you need help?
What?
Do you need help, or are you on your meeting?
What?
Do you need help?
No.
Okay.
Got it.
All right. And so after you're done with this, do 1 through 4 on your own.
You said that I got a piece of the pumpkin
Then,
cake.
I know, I just ran out of time, baby girl. Do 1 through 4 on your own and read the summary in your book. Okay? All right. And then I want you to go to,
pay attention.
I want you to go to the learning targets. And in this learning target, it just says, I can decide if a relationship represented by an equation is proportional or not, right? That's super important. That means if the equation looks like this, right? That is a proportional relationship. Okay? If the relationship looks like this, it is not a proportional relationship. Okay? Right? Anytime you have this. Or if the equation looks like this. Right? Either one of those, it is not proportional. Right? It has to have a number and an x. That number can be a fraction or a whole number. Okay? All right. So in your books, I would like for you to try question number 1 on page 133. Only number 1. So you're going to do number 1 in your books. Okay? And what I want from you on this page is if you have questions,
ABCs.
write them down on the side of the page. Okay? Write them down on the side of the page. And for tomorrow, okay? Or for Wednesday. All right, you guys, that is going to wrap us up today. And so if you have a little extra time, please just make sure you spend it reading over the Jamboard, making sure all the notes are taken down in your books. And we will see you on Wednesday. Again, I'm really sorry I missed today. I have a student meeting, or meeting for a student this morning, or actually it's noon. And so I'm just trying to get you guys in the same place as all the other classes. I don't want you to be behind. So if you could please just make sure you do this today. And there will be a sub taking your attendance. So thank you guys so much. Have a great day.
Today is victorious. Today is